Yeah, good morning, friends. We have been discussing about the maneuvers. And how does the maneuver happen? We say that for a cruise flight, lift is equal to weight. But if I want to maneuver it, I have to ensure that the lift is more than the weight. Okay? So we write lift equal to NW, where N is L by W, which is called load factor. Typically, you will find those fighter airplane, they can do a straight pull-up like this. They can do a roll pull-out like this. And for straight pull-out, now modern aircraft can go up to a load factor of 8G. Then for roll pull-out, it is between 4 to 6G. Mostly it is 4 and 5, around that. So there are always an effort to see that how we can increase the load factor to make the aircraft more agile and highly maneuverable. It's a natural choice, a natural desire, right? You should also understand the moment you sit inside a plane or an aircraft, and especially if it is a aerobatic type aircraft or a fighter aircraft, it's a natural tendency to play around with this airplane in terms of how fast it can turn, how fast it can pull up, how fast it can go from one point to another point. So there is an implicit dimension of youth, adventure and romance when you are sitting inside an aircraft. But then, as you understand, once I mix adventure and romance, we have to be very careful. It may lead to a disaster. In real life also it happens. I'm sure all young boys and girls will appreciate it more than me. So coming back to this concept of load factor and generation of load factor through airplane, I must understand one thing. Nothing will come free of cost. If I want to have larger load factor, means larger lift for a given weight. Larger lift means I have two options. If I say larger lift, I can two options. One is I need to have CL very high, or I have velocity very high. Of course, when I am talking about this, assuming that the weight and the altitudes are fixed for a given weight and altitude, right? Now see, when I say CL, I want to increase CL. What are the limitations I have got? I know that if I take a conventional aircraft and I am not using any flaps or any high lift devices, what are high lift devices? We'll be discussing, right? But by the name high lift devices, you understand there are some external mechanism which when used, they will increase the lift in terms of CL. Okay, we'll see that in detail. We'll have a session dedicated for high lift devices. But the point is this, there is a finite value, I call it CL max, and corresponding to this is alpha stall. Why alpha stall? We know by now that beyond this angle, the flow goes into a stall region where there is a flow separation, there is a vibration, oscillations of flow, a lot of increase in the drag, and so many complicated things happens. And I am not going into detail, that itself is subject. But the point which I understand as a flight mechanics man, there is a limit beyond which if I fly, I will be going into a danger zone, right? But remember one thing, when I say that, it doesn't mean if an aircraft has gone into a stall, I won't be able to recover it. A good designer ensures that to a larger extent, if the airplane goes into a stall, the pilot should be able to recover it back to a normal stable or normal non-separated or non-stall region, right? So I know as far as CL very high, it is restricted by CL max or to avoid stall, right? Similarly, you can argue, okay, I will not increase the CL to the extent of CL stall, but I will increase the lift by increasing the speed. I'll go on increasing the speed. What is the limitation? If I go on increasing the speed, what will happen? The question is this. Since I know N equal to lift by W, and N is nothing but half rho V square S CL by W. Let's say I am flying at CL max because I know beyond this CL max I cannot fly because I will be going into a danger zone, which is stall for us. So I am fixing that CL max, but I argue I will still increase this N as I go on increasing the speed. If I am increasing the speed or the velocity, what it means for an aircraft designer? You need high power engine for a given weight. High power means again weight of the engine increases, and weight of the engine increases means the wing loading changes. So there is a limitation from the engine side as well when I think in totality in terms of wing loading. However, even if those things are taken care, let's say, the problem is as I am increasing the V, number one, the load factor, if it goes on increasing, there are two issues. One is, after all, pilot, who is a human being, will be flying this machine. And all our human being mechanism or system has a limitation on the load factor, right? So beyond a certain load factor, normal human being will not be able to withstand it, because if I am going with a high G, high load factor vertically up, then the blood will try to come down, because of inertia force, and I will see dizzy, totally dizziness. Although trained pilots are there who can extend this limit of N, however, there is a limitation, right, because of human being. So that is one restriction. Second is, as I increase N, the structure also will undergo a lot of inertial load. The structure may disintegrate. The electric circuit boards may get disintegrated. So there is a structural limitation. Further, you see carefully, as I increase the speed, the dynamic loading on the aircraft structure will go on increasing with V square. And there is a limit beyond which the structure may not be able to withstand. So the structure will break. So we have to keep this thing in mind. So if I go on increasing V, the structure may break or fail because of dynamic loads. So one is CL max limit, one is limit because of N, which has pilot's limitation, then structure limitation to withstand large inertial load, and also because of high dynamic load through half rho V square dynamic pressure, the structure may break. These will draw the boundary of what is the speed and what is the load factor the pilot is safe to fly. Okay? So that is exactly called VN diagram. That is typically VN diagram represents, right? Or for a pilot, when he sees a VN diagram, he knows what are the speeds he should avoid, what is that envelope he should know a priori because he go for flight. Now let us try to draw a very simple VN diagram. We will have one more session on VN diagram, little explicit, but as I told you that we will be evolving this course along with you. I am not in favor of pumping every information at one time, right? So we'll have a very simplistic look on Vn diagram. The purpose is I have to plot V and N. I know N is nothing but lift by weight, so it is half rho V square S CL by W. Okay? Now I can use this equation to understand two things. One is for a given V, N max is simply half rho V square S CL max. What is the message you have here? Divided by, of course, W. What is the message here? That if I have put the angle of attack in such a way that it is at the CL max level, so for the given speed, that is the maximum load factor I can get. Okay. So now if I come back here, if N equal to half rho V square S CL by W. So if I try to plot V and N, so this is y equal to x squared type for other thing constant. So you will get a something like this. Okay. Now let us try to give an interpretation to this. Let us say I want to fly at speed V1. Okay. So what is the maximum load factor I can generate? That is the question. From here what we have understood, at a speed V, if you want to get the maximum load factor, you have to ensure that CL is CL max. And you cannot generate any load factor beyond N max, because after CL max, the airplane will go into stall and you are not flying in the stall. Okay. So if this is V1, I am trying to fly. Let's see this point 1. Do you think this point is N max? No, because N max is somewhere here. This is N max. This is load factor maximum at speed V1. But 1, if you see at 1, what is the meaning of that? That the load factor will not be N max. It is less than N max. That means the CL which I am flying the airplane is less than CL max. This is CL less than CL max. But if you see this point 2, what is the meaning here? Meaning here is at this V1, I am getting maximum load factor, and this point is CL max. This is CL max. Then what is this point 3? This point 3 is, it is beyond CL max. That means this point is stall region. So the pilot will not fly in that region. So this is the stall region. Please understand another very practical thing. Suppose a pilot is flying the airplane somewhere here from this VN diagram. But this VN diagram is not giving any description about the gust, wind gust available in the whole atmosphere. Right? So it is important when you are drawing a VN diagram, I should also superimpose what is the gust profile. For example, suppose I am going like this at an angle of attack, say 10 degrees, and suddenly there is an upward gust. So that will change the angle of attack of the airplane. So although pilot was not flying in the stall, but because of the gust load, it has gone into the stall region. So if you are really practical, you will see a VN diagram and then superimpose what is the gust profile at different altitude, and then draw the margin and make sure that you are never going into the stall region. So the question is now, how long I can go like this? As per the equation is concerned, for any V there is an N, but we know that I have a limitation on N max. As I discussed, it could be because of pilot's limitation, human being limitation, it could be limitation of the structure, cannot take load, inertia load. So I draw a line. So this is the limitation because of structural damage. Right? Okay. This is one point. Structural damage coming because of the inertia load. So I am limiting the inertia or load factor. Right? Further, we have seen if I go on increasing the speed, the dynamic pressure will increase. So that will also give a load. That will also may fail the structure. So I put a limit. So this is again structure damage. So there are two limitations. One is because of dynamic load, and one is because of neta, and this region is because of neta, right? We call it N, right? This is a load factor. So now, this is very important. What is this? This is also called, this I call it point B. VV is called coronal velocity or maneuver velocity. Right? What is so unique about this point? You could see if the speed of the airplane is less than VB, that is if I am flying somewhere here, VB flying somewhere here, right? This is I called VB. Let me repeat. If I am flying less than VB, all this speeds region here, so you could see that there is no way I can damage the structure, right? I can go into stall, but I cannot damage the structure, right? But if I am flying in this region, that is when V is greater than VB, then there is every possibility I can damage the structure. Okay, because once I try to fly here, I am going into that region which will cause structural damage. That is why this VV is very important. The pilot will be aware of this speed. Also, it is interesting to know that, as you know, omega is some Gn by V. So at this point, you could see very simply that neta or N is max and also CL max, right? Okay, N is max and CL also max. So this speed, if you see, is nothing but, or VB I say, let me not put star, it is 2 W by S by rho CL max. At this speed, the N is max, CL is max, and from here you could see the angular rate is also maximum. The pilot has these two information very explicitly. When he is going for flying, he will have a closer look on the VN diagram and then he will draw conclusions. Right? For the negative angle, which is not very explicit, as I am going to negative angle, the flow will separate from the bottom, right? And there is also a limit, and we will be discussing about these things in detail when I go to the next or upgraded, value-added lecture on VN diagram. But at this point, it is important you understand these two things very explicitly. Thank you.